Hello, today we are doing 6th grade math, chapter 6, lesson 3. We're going to be talking about algebra, and we're specifically talking about variables and expressions. Let's do the vocabulary startup. Algebra is a language of symbols including variables. A variable is a symbol, usually a letter, used to represent a number. So basically what this means is this. Most algebra you guys would see is like something like this, 2x equals 10. Where x is our variable, again, represented usually by a letter. That means that 2 times whatever x equals would need to equal 10. We all know right off the bat that 2 times 5 would equal 10, therefore x would need to be 5. And that's basic algebra. Another way you could have done this was to divide this by 2, divide this by 2, x equals 10 divided by 2, which would have been 5, and still solved it. Now, going on to a variable. A variable means that whatever it equals, the value varies, hence a variable. Variables are usually represented by x, y, a, b, different letters, and so on and so on. Algebra can be anything from like 5 times something or like 2 plus a equals something. But algebra is going to definitely play with variables, and that's what we need to understand is what a variable is. So again, math meaning would be something like, and you guys may want to put this in because I can't write in that small area. A math meaning would be that a letter that represents a value to help make an expression true. Everyday meaning is, variable means that it can equal multiple things. An example of a variable would be, again, something like x, y, a, b. A non-example would be any actual number, like 15, 4, 72. These are not variables because we know what the number equals. They do not vary. So let's go with some real-world links so we can explain this a little bit better. A box contains an unknown number of markers. There are 2 markers outside of the box. The total number of markers is represented by the bar diagram below. So, unknown number of markers plus 2 markers that are outside the box. Suppose there are 14 markers in the box. Find the total of markers, number of markers, explain your answer. So, right here, you get a highlighter that I like. There we go. Right here is our variable, our unknown. A variable is also our unknown. So, for example, we can use m for markers. Unknown markers plus the 2 that are on the outside will equal a total box, and we don't know what the whole box equals. They're telling us here that there are 14 markers in the box. See, this is not written very correctly. A box contains a number of unknown markers. There are 2 markers outside the box. The total number is marker represented by number of unknown markers, 2 markers. Okay. So, not written correctly, but what this should have said is that the total number of markers should have been 14 in the box. Meaning the total, all of this together is 14. And this is where it's kind of written a little weird, but this will equal 14. So m, which is the number of markers in the box, plus the 2 that were out of the box will equal 14, because the total box is 14 markers. You can solve this 2 ways. You can look and you know that 12 plus 2 equals 14, obviously, or we can do algebra, which is this invisible little line around the equal sign. It's kind of like a mirror where this right here has the equal 14. But what we want to do is we want to get the variable by itself. So what I would do is subtract 2 here and subtract 2 from the other side. This will equal just m equaling 14 minus 2, which is 12. And if we plug this in, 12 plus 2 does equal 14. Therefore, m, or the number of markers that were in the box, is 12. And that's how we find our variable. An algebraic expression An algebraic expression contains at least one variable and at least one operation. It's very, very important that we add that to our notes. So let's go ahead and recover that. An algebraic expression contains at least one variable and at least one operation. An operation means addition, subtraction, division, multiplication. Something is happening. For example, the expression n plus 2 represents the sum of an unknown number and 2. N is our variable. We don't know what n equals. And this is just an expression, n plus 2. The second I say that it equals something, it no longer becomes an expression, it becomes an equation. So please make sure that's in your note. An expression is literally without an equal sign, just n plus 2. N can be any number, it can be any variable. The second you put an equal sign and a number after the equal sign, it becomes an equation. Because now n can't equal anything. N plus 2 has to equal 14, which means that n has to be 12. So please make sure you understand the difference between an expression and an equation. Down here are a few expressions. Notice there's no equal sign. 5 dot x, which means 5 times x, or 5 and then parentheses x, which also means 5 times x, or just 5x. 5 next to x means 5 times x. All three of these mean the same thing. It's 5 times x. Whenever you see a number next to a variable, it means you're multiplying it by it. So as you can see, I have 7x, which means 7 times x, 8n, which means 8 times n, and 9a, which means 9 times a. You can rewrite these. Not 100% sure why it's not letting me erase. There we go. You could also write these like this. 7 dot x, or 7, and then parentheses, x, and then 7x. These all mean the same thing. These are all 7 times x. And the variables in an expression can be replaced with any number. Once the variable has been replaced, you can evaluate or find the value of the algebraic expression. So for example, 5x. This could represent something like person makes $5 an hour, where x represents the number of hours they work. So however many numbers of hours you work will depend on how much you get paid. So this is kind of like, this is an input-output value. So if you work 1 hour, 5 times 1 is 5. So you make $5. If you work 2 hours, where x would equal 2, 5 times 2 would be 10. So you'd make $10. And let's say x equals 10 last. 5 times 10 would be 50. You'd make $50. This is where an expression comes into play, because x can now equal anything because there's no equal sign. The second I put an equal sign here and I say this has to equal this, I have math that I need to solve. This no longer becomes an expression, it becomes an equation. So I'm going to divide this side by 5 to get x by itself, and I'm going to divide this side by 5. 35 divided by 5 is 7. Therefore, x has to equal 7. X times 5 will be 35, which will make this statement true. So again, this right here, 5 times x equals 35 is an equation. Without the equal sign, 5x is just an expression. All right, we have a few examples here. Evaluate 16 plus b if b equals 25. Now they're giving you the actual representation and the value of the variable. So 16 plus b would be the same thing as 16 plus 25, or 41. Evaluate x minus y if x equals 64 and y equals 27. We're literally just plugging it in. X minus y, x equals 64, y equals 27, so it's 64 minus 27, which equals 37. And then evaluate 6 times x if x equals 1/2. 6 times x, or 6 times 1/2, would be 3. And for those of us that need that refresher, it would look something like this. Remember, when we multiply by a fraction, I don't know why I put 1/3. It's supposed to be 1/2. I need to put my whole number over 1. And remember, when we multiply fractions, we just multiply straight across. So 6 times 1 will equal 6. 1 times 2 equals 2. This is an improper fraction, so I'm going to simplify it just by dividing numerator by denominator. 6 divided by 2 equals 3. Therefore, 6x, when x equals 1/2, will be 6 times 1/2, which equals 3. So we're going to go ahead and do these got it's. A plus 8 if a equals 6. 6 plus 8, you can pause it here, solve it. It should equal 14. A minus b. Remember, a is 6, b is 4. So 6 minus 4 would be 2. A times b. A equals 6, b equals 4. 6 times 4 would be 24. And then c, where 9 times c, c equals 1/3. So this will be 9 times 1/3. We'd have to put 9 over 1, and we'd multiply straight across. 9 times 1 is 9. 1 times 3 is 3. Improper fraction. 9 divided by 3 would equal 3. And that's all there is to it. And I know this is probably really easy, but these are baby steps right now. All right, sorry about that. We're going to be talking about evaluating multi-step expressions. So to evaluate multi-step expressions, replace each variable with the correct value and follow the order of operations. So for example, and I'm going to go ahead and write this on the digital whiteboard, 5t plus 4. I'm going to erase this. 5t plus 4. And this is where things are going to get a little confusing, especially when variables like, for example, 5x, and then you're multiplying again, there's another one. So my hint to you guys would be to do this. 5t, and make the plus sign smaller so you know that this is a variable. So 5t means 5 times t plus 4. So order of operations says we need to do the multiplication first. We are going to have to do 5 times t first. T will equal 3. So we're going to rewrite our expression, because this is not an equation, because there's no equal sign. We're going to rewrite our expression as 5 times 3 plus 4, because t will equal 3 in this example. PEMDAS tells me I need to do multiplication and division first. So this will become 15 plus 4, because I have to do 5 times 3 first. Once that is done, 15 plus 4 will be 19. Therefore, 5t plus 4 will equal 19. And t would have equaled 3. Evaluate 4x squared if x equals 1/8. 4x squared if x equals 1/8. So this is where things are going to get a little tricky. Remember, PEMDAS is parentheses, exponents, multiplication and division, and then addition and subtraction. This is an expression. We will have to do that first. So this means it's 4 times 1/8, but 1/8 is squared. So I have to square the 1/8. 1/8 or 1/8 times 1/8 will equal 1/64. So this will now become 4 times 1/64. That will in turn become 4/1 times 1/64, which will be 4/64. And that is a proper fraction, but we need to find factors of both. And if I'm not mistaken, 40, let's guess and check. I want to say 64 can be divided by 4. 64 divided by 4 equals 16. So that will equal 16. 4 divided by 4 will be 1. So my answer is 1 over 16. And that's exactly what they got here. So again, there were no parentheses. There were exponents, so I had to do the exponents first, which was 1/8 squared, which means 1/8 times 1/8, which is 1 over 64. Then I plug that in to multiply by 4, and it becomes 4 over 64. And we simplified it to become 1/16. And last but not least, we are going to talk about evaluating 10a plus 7 if a equals 1/5. 10a plus 7 if a equals 1/5. Let me double check to make sure that's right. 10a. So 10 times a. We're going to rewrite this. This means 10 times 1/5 plus 7. We need to do this first. This will become 10 over 1 times 1 over 5, or 10 over 5 plus 7. I want to simplify this 10 over 5 first, which means 10 divided by 5, which would be 2. That would become 2 plus 7, which would then become 9. And that was my, oh, they didn't do the work here, but that is my answer. Because remember, we'd plug in the 1/5. 10 times 1/5 would become 10 fifths. 10 times 1, 1 times 5. And then 10 fifths is an improper fraction. Numerator divided by denominator would make that 2 plus 7 equals 9. All right, we're going to go ahead and end that lesson here. If you have any questions whatsoever, please ask. I'm not going to tell you your homework today since this is possibly going to be a double video night. So we're going to go ahead and call this one a video, and I will see you guys on the next one.